Hello there guys, welcome back to another epic and extra real maths video. In this video, we're going to be live streaming some A-level maths content because the final A-level maths exam, paper 3 of 2025 is upon us. It is tomorrow, okay, which is very exciting, but also very scary for many people. So we're going to be going through some content. Now, just as we wait for everyone to join, by the way, guys, please, if you join, let me know how am I sounding? Is the music too loud? Let me know what's going on with this. But today we're going to be looking at some statistics content primarily. Look at this strand of hair. Oh, it's so weird. It's so weird. I hate wearing headphones for this reason because my hair always like does this. Very strange. Give me 1 second. That's better. That's better. So, yeah, now it's all stretched. It doesn't matter. It's not about me. So, guys, we're going to be taking a look at some statistics content. Now, my reasoning for why we're doing statistics is because the edXL lot have done all of their pure content already. They are doing, oh, hello, all 22 people. I'm absolutely blessed and privileged. Please leave a comment. Leave a comment. Let me know how you guys are doing. Yay. Please go through nasty probability question. Yes. I remember you. Of course, we're going to go through some probability. So just to finish my thought on that, and please do let me know, guys, if my signal is good or bad, because it's saying that I have 1 bar. It says the connection is unstable. So please do just let me know if I'm like cutting out or breaking up or if I'm okay. Please do let me know. But yeah, just to finish my thought on that, edXL have done all of their pure content already because paper 1 and paper 2 are 100% pure and their paper 3 is half mechanics, half statistics. So they haven't done statistics yet or mechanics. AQA, which is probably the next biggest exam board, have done a paper of pure content and a paper of half pure, half mechanics. So AQA have finished mechanics, but not finished pure. So for AQA, the paper 3 is going to be half pure, half statistics. And I don't know about other exam boards like OCR. I'm not 100% sure. But I tutor edXL and AQA, and I know that for sure. So the overlapping content there is that neither edXL nor AQA have done any statistics yet. So that's why I'm thinking I want to go through some statistics. By the way, guys, have a go at the little starter on the board if you want to have a go at that. If that's readable, I can make it a little bit bigger if needed. Please just let me know if that is something that you would like me to do. I'll make it bigger when we actually get into it. But yeah, guys, please, please, please do let me know whether or not I'm cutting out and breaking up or if the connection is good. I really, really want to know. Just in case there's anything I can do to fix it. Please let me know now if you are able to, whether or not my signal is good, am I cutting out, etc. I'm just also going to just check myself as well here. Let's have a quick look. I'm just checking. Oh, Dev says I'm all good. I appreciate that. Thank you very much. I'm just going to try and connect to my own live stream here for a second, just while we get going. Again, please, guys, if you need something to do, have a go at that question on the board. That's a statistics question. Obviously, feel free to use a calculator and whatnot. But yeah, I'm just going to wait a second, let some people join, let everyone ease in. Let me know, guys, how well you're doing. Let me know how confident you're feeling as well for the next paper. How did the previous 2 papers go for you? I'd love to know. I tutor AQA and edXL, and it's interesting what some people have said. I'm under the impression that there has not been any first principles. So first principles just didn't come up for edXL students. And also binomial expansion just literally didn't come up. And barely any straight lines, if I'm not mistaken. And it sounds like AQA, it might be on a similar path. So I'm not telling you guys explicitly what to revise, but what I am saying is that if you're an AQA student, you've still got 50 marks worth of pure content in your exam tomorrow. I'm not telling you what to revise. This could end up being bad advice. But a serious thing is there's a high chance that binomial, if you're an AQA student, just won't come up. There's a high chance that differentiation by first principles just simply won't come up. So really, really strange, but it could happen. Okay, I'm not telling you that it won't, just to be really clear. I would still highly recommend revising it and making sure you know how to answer those questions. But it's interesting that it didn't come up at all for edXL. Really, really funny, actually. Very strange. So again, guys, I'm just trying to connect to my own live stream here for a second, just to make sure that my sound quality is really, really good. Please, thank you, Dev, for confirming that it is. I just want to quadruple, not that I don't trust you, obviously, but I just want to, you know, triple, quadruple, jumbo check. Virat says, hi, hello there, welcome to the live stream. We're going to get on with some stuff soon, but right now I'm going to take you, I might take you guys' word for it, because I can't actually connect to the live stream for some reason. Oh no, it's working now, forget about it. No, it's going well. The sound quality is good, actually. Okay, I've just checked. Okay, not that I don't trust you guys. Okay, cool. So, guys, as I say, please do have a go at the question on the board. This is a statistics question. Everyone should be doing statistics in their third paper. Regardless of whether you do AQA, edXL, or anything else, you should be doing statistics in your third paper, as far as I'm aware. So have a go at the question. Let me know what you get as an answer, and we will see what happens. Obviously, feel free to use a calculator, etc., all the normal stuff, but have a go at it, and we're going to actually get into the content very, very promptly. The paper 2 live stream that I did only lasted less than an hour, because I just moved into a new house the other week and I was setting stuff up. I was super, super busy. You guys can probably see in the background here, the house. Got some posters there. That's Jaws, Vertigo, and you can't really see it, but It's a Wonderful Life. We've got there. I've got some cool little artifacts in this room. I'm a big film buff. I love films. Not that those films are like underground or anything, but you know, not to be. I didn't want to get any film bro films. You know, I think Jaws is kind of a film bro film, but not really. I think when I think of film bro, I think of Tarantino. I think of Pulp Fiction and Kill Bill. I think of what else? Maybe some kind of, you know, neo-noir kind of stuff like Taxi Driver, Goodfellas, or gangster films, mob films, but then neo-noir films too, like Nightcrawler, even Joker to an extent. But that's kind of, I didn't want any of that stuff. My favorite film of all time is La La Land, but I think a La La Land poster, one, it wouldn't really fit the aesthetic of this room, because it would probably be purple, and two, it's slightly film bro. It's slightly film bro, and I want it to be a bit different. You can't go wrong with the, you know, Jaws. No one can dispute that it's an absolute classic. Virat, I respect that. Yeah, La La Land's an amazing film, and I won't be taking any La La Land slander in this live stream from anyone. Me and Virat are going to come and mess you up if you do. It's a great film. I really, really like that film. I've seen it loads of times. Funnily enough, I feel like, actually, to an extent, with me at least, I feel like people say, what's your favorite film? And I say, well, I suppose it's La La Land, but it's not really a conscious choice for it to be my favorite film. But when I reflect on it, it's like, that's the film that I like the most, and I can't control the film that I like the most, if that makes sense. So you don't really choose your favorite film as far as that goes. Maybe your second, third, fourth, you can kind of choose them, but I feel like your favorite film is one that it just simply is, you know. It's not a decision. My letterboxed top 4, by the way, guys, is La La Land, The Seventh Seal, by Ingmar Bergman. Old Boy, the original, guys. Come on. And a documentary called Grizzly Man by Werner Herzog. I really, really like that film. That's my Letterboxd top 4. So, yeah, Virat, it is absolutely, it's an emotional roller coaster every single time. Not to spoil the ending. I feel like everyone kind of knows the ending of La La Land, but I'm not going to spoil it. But every time I watch the ending, there is something transcendental about the way that I desperately want the film to just end in a different way. You know, I know how the film ends. I've seen it a dozen times. But every time, by the time I get to the end of that film, I'm just wishing that it ends the other way. But it never does. It's amazing. It's an amazing film. I'm pretty confused of what this stream is about, by the way. It showed up on my For You page and it seems intriguing. So I hopped on. Well, thank you, Virat. Well, just to be really, really clear, on your For You page, is that on YouTube? If it wasn't on YouTube, then that's very fascinating. I don't know how it would have got there. For You page, I'm assuming it's YouTube, right? But this is, just to be really clear, this is the A-level maths paper. The final A-level maths paper is tomorrow. So I'm doing free tutoring for anyone and everyone that's doing that exam, or just if there's not enough people that want me to go through any specifically A-level maths content, I will, yes on YouTube. Okay, yes on YouTube, that's cool. I will be going through any maths related content that anyone wants, but obviously we're going to be prioritizing content that's going to come up on paper 3 of an A-level maths paper. Now, the tricky bit here is that different exam boards have got different content, but statistics should be common to every exam board. As far as I know, statistics is paper 3 for every exam board. Please correct me if I'm wrong, but it definitely is for Edexcel and AQA. So Virat, I don't know if you're much of a mathematician, but please, if you are, 100% check out the channel. Oh, I was preparing for the SAT. I'm not from the United States. I am not from the United States either. Luckily, I am from the United Kingdom. Or did you mean that you are from the United States? Well, if you need some mathematics help, then this could still be useful. I don't quite know what's on the SAT. I'm not 100%, but I don't know. Maybe this could be useful for you. I'm sorry for assuming. Hey. That, I mean, apology accepted. No hate towards the Americans. They've got their own business. They've got stuff going on over there. No hate though. Okay. Right. Let's get into some mathematics, guys, because it's been long enough. So, guys, everyone who's tried this question, I need you to send in a little message in the chat right now with what you think the answer is. And just to be clear, if you're wrong, it's okay. It's okay. Don't you worry. I'm not going to shout at you. I'm not going to manifest into some sort of childhood trauma that you may have, may or may not. I'm going to just say, not quite. Okay. Road to IIM. Anyone preparing for CAT 2025? I don't know what that is. I do not know what that is. That's the cognitive abilities test. Or maybe common admissions test. Common admission test. Wow. Okay. I don't know what that is. It's a computer-based standardized test administered by the Indian Institute of Management. Wow, that's brilliant. Well, do you know what? I don't know exactly the difficulty level or the skill level here for the CAT 2025, but we're going to be doing some probability and statistics. So you may be interested. Maybe. So guys, please do leave a comment. Leave a comment if you know the answer to the question on the board, at least for part A. Does anyone know the answer to part A of question 11, the question that is currently on the board? If you know, leave that comment and you might get a sweet treat. Okay. And by sweet treat, I mean you're not going to get anything, you loser. I'm just joking. Okay. Kamal says, could equation of trajectory come up in mechanics? It certainly could. It certainly could. The equation of the trajectory of a projectile is a quadratic equation. There is a formula for it. I might do some mechanics later on, but for now we're going to do some statistics. But yeah, Kamal, 100% that could come up in your A-level maths exam if you're doing EdXL, I guess, because AQA, it's already happened. The mechanics has already happened. Please leave any questions that you might have in the chat below. I want to know. I want to know. And guys, no one has left an answer to this question yet. I want to know. Let me adjust this. Made it slightly bigger. JN says 203, sorry. 203.37. You're absolutely right. Thank you very much. Guys, look at this. A shining example. JN, you're on the screen. 203.37. Well done. Well done. Guys, be like JN. Okay? Because JN knows what he, she, they, I don't know, are talking about. All right? Well done. Guys, we're going to go through it, but JN has absolutely got it in the bag. So let's check the question out. We're going to start. An automated pottery wheel is used to make bowls. The diameter of the bowls, d millimeters, is normally distributed with mean mu and standard deviation 5 millimeters. Given that 75% of bowls are greater than 200 millimeters in diameter, find first of all the value of mu. Okay, so guys, this is obviously a statistics question. This is a normal distribution question, and we're going to go through it right now. So whenever you get a normal distribution question, what I like to do is I like to draw a little bell curve so I can kind of visualize what's going on. I can see it in actually a diagram. So that's what I'm going to do right now. So I'm going to grab, yeah, that's a good thickness. Okay. Here's my, okay, it looks pretty bad, but there's my normal distribution. Okay. This isn't art A level. This is maths. So it's okay for me to be that bad. All right. So what do we know? What information do we get given? Well, mu is always in the middle, so I'll label that mu. And we know that the standard deviation is 5. So I know, and they're using the letter D, that D is normally distributed with a mean of mu, that's kind of unknown, and a standard deviation of 5. So I'm going to put 5 squared there because actually the variance is what goes there. Hopefully that all makes sense so far, guys. And actually, let me just move. Sorry, JN, I'm just going to move your thing so everyone can see that a bit better. Please let me know, by the way, if the music is too loud or anything like that. If you want me to mix up the genre, I'd be happy to do that. Just let me know, guys. Anyway, that's the diameter. And the final bit of information that we get given is that 75% of bowls are greater than 200 millimeters. So 75% are greater than 200 millimeters. So maybe about here is 200. So that the area to this side is 0.75. That means that this area is 0.25. So now, guys, we're going to go into the calculator and we want to go to the inverse normal distribution. So I can't really show you this on here, but we're going to go to the inverse normal distribution on the calculator. Okay. And we're going to, and unless, guys, am I missing something? Am I doing it the long way? Am I doing it in like a funny way? Or is this how you're supposed to do it? Because what I would do is I would go inverse normal distribution. We don't actually know what mu is. So we're going to keep it as the standard normal distribution. And I'm just going to put the area as 0.25. Okay, so let me just go down here and show you what I'm doing. I want to know from JN if JN did it in a different way or if JN did it in the same way as me. But I'm now going to draw a diagram of what you call the standard normal distribution, which looks the same, but it has a mean of 0. And this is Z, mean of 0, and a standard deviation of 1, and a variance of 1. And what I'm doing is I want to find this such that this area here is 0.25. And the value that I get there is minus 0.67449, roughly. And then we can use the equation that links the standard normal distribution to any given normal distribution. And that is that Z is equal to X minus mu over sigma. Okay, so that means that minus 0.67449 is equal to X, which is 200. You can see that this is the 200. Have I just deleted the page? I think I have. It's back. It disappeared for a second, but it's back. Minus mu, which we don't know, divided by the standard deviation, which we get told is 5 in the question. Okay. Hopefully that all makes sense, guys. Then we just rearrange. So we're going to multiply both sides by 5. And we're going to get minus 3.3724479 is equal to 200 minus mu, which means that mu, moving over, is going to be 203.3724479. And that's going to be the answer. So mu is 203.37. And I believe that's also what JN got as well. It absolutely is. Let me just move down slightly. Or actually, I'll zoom out. Hopefully this is still legible, or it might not be. Maybe just about. And if I put it, if I can see the whole question at the same time, that was part A. Okay, hopefully that makes sense. You guys are happy with that. Please let me know if anyone wants me to elaborate any further on this question on the normal distribution. Please do let me know. But I think that's probably satisfactory. Okay, I will assume that everyone is happy with that. Okay, moving on to part B. Find the probability that D is between 204 and 206. So now this is very easy of a question. Because we can just type this into the calculator. So now we know that D is normally distributed with a mean of 203.37 and a variance of 5 squared, or standard deviation of 5. That means that the probability that D is between 204 and 206 is very simple. You just type it in on your calculator. So going into distribution, going into normal CD, when you use the normal distribution, you're always going to be using CD. You got your lower bound as 204, upper is 206, standard deviation is 5, mean is 203.37, and as an answer, what we get is 0.1504. Okay. Is everyone happy with that? 0.1504. Hopefully everyone's chilling with that. Okay, now let's go on to the final part of the question. And that is, find the probability that all of, oh, and I should have actually read this out first. 3 bowls are chosen at random. Then, for 3 marks, find the probability that all of the bowls are greater than 205 millimeters in diameter. So this is a species of question, you might say, that a lot of people struggle with, because actually this one, to an extent, it is also going to be binomial. You don't really need to think of it as binomial for this one, but the idea of combining binomial and normal is a bit of a tricky one for a lot of people. So, do with that what you will. But that's the idea. So how are we going to do this? Well, first of all, let's work out the probability that any one given bowl is greater than 205 millimeters in diameter. So in other words, what is the probability that D is simply greater than 205? Again, just going into the calculator, that means my lower is 205 and my upper is a very, very, very big number. And that's given me 0.37221. Lovely. Okay. So before I give the answer away, does anyone have any ideas on how we might do this? Now that we know the probability that any given bowl is greater than 205 millimeters in diameter, how would you find that when 3 are chosen at random, all of them are greater than 205 millimeters? How would you calculate that? This one is not actually too bad. The problem is when you get a question where it's like, what's the probability that at least 2 are greater than 205 millimeters in diameter or something like that? That's where it gets a little bit, for a lot of people, a bit tricky, because you really do need to kind of deal with the binomial distribution. Okay, so guys, I'll tell you, because no one has said. What we're going to do is simply multiply 0.37221 by itself, and then again. So we're going to cube this number, basically. Okay, and that's because they're all independent events. So the probability of all 3 of them having this quality to them, we have to multiply each of the probabilities together. So we cube it, and we end up getting 0.05157. Or you could say 0.052 or something like that. Okay. Is everyone happy with that? Oh, Charlie says binomial PD, x equals 3, n equals 3, p equals 0.3722. Charlie, you're absolutely correct. You could also do that as well. So I just cubed it, but you're right. It is the equivalent of just doing that. So it's exactly the same thing, 100%. And actually, I think that the way that you've done it is better because, again, as I said earlier, what you can sometimes get in the exam is them not just saying what's the probability that all 3 bowls are greater than whatever. It might be what's the probability that less than 2 are greater than whatever, or bigger than 2 or whatever. And in that case, you really do need to use the binomial distribution. So that would absolutely be what you do. But what you've typed, which is completely correct, is the equivalent of simply cubing the number. Okay. Is everyone happy? What the hell? Right, guys, I'm back. Apologies for that. Not 100% sure what happened. We lost StreamYard. We lost StreamYard. We're here. I'm using StreamYard just so I am back, guys. No worries. So let's reconnect to the whiteboard and continue. So yeah, do apologize for that. Probably look like I got smited off the face. Okay. Oh, it zoomed in. Oh, and I'm gone now. No. Nope. Hey, okay. All right, guys. A little bit of chicanery, but we're back. Anyway, that is that question. So, guys, on a scale of 1 to 10, how are we feeling about it? How do you guys feel about that question? Guys, please do just leave a comment. Leave a comment in the live stream if there is anything at all related to A-level maths, please, that you would like to cover. And your wish is my command. Okay. We can go through any question, preferably stats, but if it's not stats, that's okay. We can go through pure, we can go through mechanics, because again, different exam boards they've all got different stuff. Some people have stats and pure, some people have stats and mechanics, but stats is the it's the underlying part of it. Charlie says any hypothesis questions. Okay, amazing. Let's go through a hypothesis testing question. I think let's keep with the normal distribution aspect of it, and we'll go through a hypothesis test question on the normal distribution. I think that's actually a great idea because they are the tricky ones. So right, let's go with this question. I'm just going to import a question here, guys, and I will be with you in a second. Okay, that's the thing about doing this one-handed. I should have like a mic holder, shouldn't I? Like a mic holder, and then I can just speak into it like this. I used to have one for a different microphone, but not anymore. Okay. Hypothesis testing, it's happening. So let's go down here and bear with me for 2 minutes as I sort us out a hypothesis testing question. Give me a moment. Okay. All right. Here we go. And that's probably the best way of doing it. Okay, cool. Right. So guys, this is a classic type of hypothesis testing question that you can be asked in A-level maths about the normal distribution. And yep, it's in many ways quite difficult. So let's run through this. So the IQ scores of a population are normally distributed with a mean of 100 and a standard deviation of 15. By the way, guys, fun fact, that is pretty much definitionally what an IQ test is. It's standardized so that the mean is 100 and the standard deviation is 15. Okay. Anyway, it's normally distributed with a mean of 100, standard deviation of 15. A psychologist wishes to test the theory that eating chocolate before sitting an IQ test improves your score. A random sample of 80 people are selected, and they are each given an identical bar of chocolate to eat before taking an IQ test. Find at the 2.5% level the critical region for this test, stating your hypothesis clearly. So again, the critical region is the region, the range of values of your parameter, I suppose, that would result in you rejecting the null hypothesis, basically. So basically it's the region where if you get your, I'm trying not to give something away right now, but if you get your thing X, or maybe it's something else, maybe it's X bar, if that thing ends up being in your critical region, you would reject the null hypothesis. That's what it is basically. So that's what we're trying to look for. Now, the trouble with this question that many people will have is they do it wrong, but they do it wrong in a very specific way that I'm going to explain right now. So first of all, let's write down the null hypothesis and the alternate hypothesis. Okay, let's start with that. So, and by the way, guys, please follow along if you want to, and tell me what you think the upcoming answers will be, etc., etc. All right. The null hypothesis, because we're testing to see whether, and let's just make sure we understand this. A psychologist wishes to test the theory that eating chocolate before sitting an IQ test improves your score. Okay. So the null hypothesis, when you do a normal distribution question like this, is that the mean after eating chocolate is the same as the mean before eating the chocolate. So mu is just 100. The alternate hypothesis is that mu is bigger than 100. The mean would be larger than 100 because the mean IQ test score would have increased. Okay, that's the two. Those are the two hypotheses, I suppose you could say. Now, in a real exam, you should definitely specify. You should be a bit more specific as to what mu is. So, in a real exam, I would say mu is the mean IQ score of people after eating chocolate. Okay. Cool. Now, we also can state that X, if we say X is the IQ score of one person after eating chocolate. Because when you do a hypothesis test, you're always assuming the null hypothesis is true, we can just say that X is distributed how they've said that it should be in the question. So that means that X is normally distributed with a mean of 100. We're assuming this under the null hypothesis, and a standard deviation of 15. So we would write it like that. Now, again, this is what most people that make a mistake on this question will do. This is their mistake. They will go onto their calculator at this stage, and they will use mu as 100 and sigma as 15, and they will find the critical region in that way. That is wrong. Why is that wrong? Because in the question, we're not measuring a critical region for one person, but rather a sample of 80 people. And we're looking at not just X, the result of one person, we're looking at the mean performance, okay? So once we've written down what X is, we also need to make a note of what X bar is. So this is the distribution, the probability distribution of the mean IQ scores of these people after eating chocolate. And under the null hypothesis, we would say the mean is still 100. And this is the tricky thing. When you have and I'm going to write this down formally in a second, but when you have the distribution of the mean of a variable, the mean stays the same, but the standard deviation does not, or the variance does not. The variance gets multiplied by the sample size, which in this question is 80. Okay, there's 80 people. Okay, now you might say, what's going on? If you're a bit shoddy or shaky with this, so I'm going to write it down. Really important. If X is normally distributed with a mean of mu and a standard deviation of sigma squared, or a variance of sigma squared, then the distribution of the mean of X, and I'm going to write it as Xn. That means it's the mean of X with when there are n samples. Okay, so in this case, n would be the number 80. This is just notation. Would be normally distributed, still with a mean of mu, but a variance of sigma squared over n, okay? That means that the standard deviation becomes the standard deviation divided by the square root of n, okay? When you do this. This happens because of an incredibly important result in statistics called the central limit theorem. Hugely important and very complicated. So I won't try and explain it because it's very, very complicated. I'm actually not, even myself as someone who's doing a maths degree, not actually going to see a proof of the central limit theorem until next year. That's how complicated it is. So I'm not going to try and go into the details on that. Okay. So that's it. Now, that's the distribution of the mean. Okay. Now coming back over here, changing back into white. Okay. Again, because it's a normal distribution question, I'm always going to do myself a favor and draw a little diagram. So I'm going to draw myself a little bell curve here, like that. And I'm going to say that the mean, because again, I'm assuming under the null hypothesis, the mean is 100. And I'm looking for the critical region. Now, the alternate hypothesis is that mu is bigger than 100. So the critical region is going to be on the right-hand side. And what's the significance level of this test? 2.5%. So what I'm looking for, guys, is I'm looking for this value here such that this area is 0.025. That corresponds to 2.5%. Okay. How do I do that? Well, I'm going to go onto my calculator, distribution. We can go into inverse normal. Area, I'm going to have to write it as 0.975. Some people's calculators will allow them to type in 0.025, but my calculator doesn't. So that's that. The standard deviation is not 15 anymore because we're using this thing. So actually the standard deviation is 15 over the square root of 80. Okay. So when I type in my standard deviation, I'm going to be typing in 15 over the square root of 80, just to be really clear. So 15 over the square root of 80. And the mean is still 100. You can safely type in 100 as the mean. And the value that I get here is 103.28699596. And actually, guys, I'll quickly tell you if you're curious. If you had just typed in the mean as, or the standard deviation as 15, then that value would actually be as high as 129.4. So it would take a lot more to reject the null hypothesis if that was the case. The critical region would be much further away. But because we're dealing with a mean, if the mean of a group of data is even a tiny bit different, it's a red flag. Because, you know, the law of large numbers. As your sample size increases, everything should look pretty much the same. There isn't space, there isn't room for outliers to make a difference with such a large sample size. So that's the issue. So when you have a large sample size, the critical region is actually going to be quite close. It's not going to be too different when you're dealing with the mean because of that reason. So that's the answer. The answer is X bar is greater than 103 point, let's say 29. That's the critical region. Critical region. Boom, boom, boom. Okay, and just so you can see the question again, that's what it looks like. And that's what they asked. Okay. And I'm just going to go and check that in the textbook just to make sure I'm not missing anything, make sure I'm giving you guys the exact correct information. And yep, that's the answer. Lovely. Okay, is everyone happy with part A of that question? Please let me know if you have any questions. I will be happy to elaborate as much as is needed on that question if anyone has any issues with it. And again, it's completely fine if you do. Or is everyone okay? Sounds like everyone's pretty chill. By the way, guys, I'm going to mix up the music because we got to mix it up. I don't even know what genre of music you'd call this, but it's just simply got to be changed. Not a fan of rock in this context. Okay, this is all right. Anu Bahav, oh, I've probably butchered that, says hi. Hi, hi, hi. Welcome, welcome, welcome. We are doing a little bit of A-level maths before the final exam, which is tomorrow. If you do want to go through anything in particular, please let me know. I'm going to finish this question, part B of it. We haven't finished it yet. The gaming, Sunio, hello there. My fellow gamer. I only play Clash Royale and Fortnite. Okay, so I don't know if that's quite living up to your name of being a gamer. I just reinstalled Clash of Clans, guys. Clash of Clans. How times have changed. Charlie says, for B, I get 0.02524, which is greater than 0.025. So accept the null hypothesis. Okay, let's get to it. Let's see what that's saying. And the Gaming Suno says, Clash of Clans is the OG. You're right, you're right. Charlie says, what's your deck on Clash Royale? I'll tell you my deck, guys, and I'll tell you how many trophies I got, because I'm low-key, guys, I'm low-key kind of like cracked at Clash Royale. I'll tell you, and then we'll go on to the question, because I'm sure there's some people that do not care at all, but I'm interested, so let me tell you. And oh, Charlie, tell me what your deck is as well. So my main deck, I've used this for a long time now, and guys, I don't want to big it up, okay? I don't want to overhype myself, but I'm being quite serious when I say I genuinely believe this is the best deck in the entire game, because every time I even think about my Clash Royale deck, I'm marveled, I'm amazed by how clever it is and the ability to just counter absolutely everything. Before I tell you the cards, we have 2 buildings, so it's immune to like Hog Cycle, Hog 2.6 or whatever you call it. Got some, I think, really good evolutions. It's decent skill, like it has some low skill cards, but also I think it has some, well, it's fairly easy to use, I would say, but like you can also be skilled with it, and everything is pretty strong. So let me tell you guys. So the 2 evolutions. Oh, the Gaming Suno says, actually, I'm from India. Just gave JEE Advanced, if you've heard of it. Yeah, I know the JEE. Got all India rank of 72. Now, I don't know what that means. Does that mean you came 72nd in all of India? If that's true, then you are literally the next Ramanujan, my friend. That's amazing. Charlie says, Evo Dark Goblin, Evo Valk, Goblin Gang, Arrows, Log, Goblin Barrel, Inferno Tower, and then Prince on Mini Pecker. Let me visualize this. So Evo Dark Goblin, Evo Valk, okay. Goblin Gang, Arrows, Log, Goblin Barrel, Inferno Tower, Prince. Okay, that's pretty solid, to be fair. I don't see an issue with that. I have to like visually see it, but that, yeah, that's good. This, yes, 72nd in all of India out of 15 lakh. I know there's a lot of people in India, so that is crazy. 72nd. That's brilliant. I mean, quite a lot of my viewers on this channel are Indian. I think it is a lot of people from, doing JEE. 150 million people. No, dude, that's actually crazy. You came 72nd out of 150 million, bro. Oh, sorry. Okay, 1.5 million, but that's still crazy. That is actually insane, dude. Well done. Well done. Okay, let me get to my Clash Royale deck. So we've got Evo Goblin. Sorry, I've already butchered it. Evo Mortar. I said Goblin because it has the Goblin on it. Evo Mortar. Okay. Evo Royal Recruits. Mighty Miner. Dark Goblin. Skeletons. Inferno Tower. Log. Fireball. All right. Read that again. Okay. Evo Mortar. Evo Recruits. Mighty Miner. Dark Goblin. Skeletons. Inferno Tower. Log. Fireball. And I've got how many? And by the way, guys, I've never ever spent a penny on this game, and I can proudly say that. I'm on 8,846 trophies, so I'm pretty nearly at 9,000. But I'm really worried. Like, I don't really want to play because I feel I'm just going to go into a spiral again and just like lose loads of games, which I've done before. I like it. I think it's like a relatively new feature, like only the past few years, where they've made it where if you get like once you get to a new arena, you can't go back. Oh, Charlie, you got 8,600. We're probably really, really similar level then. That's great. But yeah, that's basically that's my deck. It's great. It's really, really good. And like, even though obviously it's a pretty high trophy count, 8,600, 8,800. I can still do stuff where I'm like, I can't believe I'm getting away with this. Like, you take one tower, right? Take a tower, and then you basically, yeah, try it. Do you have it? Do you want me to say it again, or have you got it? But you try it, right? And okay, this is the strat, and I can't believe this still works, but it actually does, even at this, this big level. You take someone's tower once you get the tower, then you just create a massive push in the lane where they are missing a tower with the Mighty Miner in about the middle. And then they obviously respond to it because they think that you're going for the King Tower. And once you get to the same like latitude of the other Princess Tower, you just lane switch the Mighty Miner. And the Mighty Miner just appears on top of the other Princess Tower. And even though it's like so obvious that you can do that, people fall for it every time. As long as you don't like continuously make the Mighty Miner switch. Normally the way I play Mighty Miner is I only make him lane switch to get rid of hordes. Like if someone puts down a minion horde, I just lane switch him because it's like it costs 1 elixir to make him switch lanes, and it can just delete a minion horde or a skeleton army or a goblin gang or whatever. But other than that, I pretty much never make the Mighty Miner lane switch because if people get used to it, they anticipate it. So I sometimes go whole games without ever making it switch. But if I take the first tower, I'll make him lane switch right at the end onto the other Princess Tower. And yeah, Mortar is really, you got to keep the pressure up really high with Mortar. But Mortar is so good because, and I have it as an Evo. So what happens is whenever I play Hog, because Hog is so common, they place 4 elixir down and they drop their Hog Rider. You can counter the Hog Rider with a Mortar because you just put the Mortar down, and sometimes I have to put skeletons as well, which only cost 1 elixir, so it's -1 elixir. But the Hog gets 0 damage on the actual tower, and the Mortar always gets 1 hit. And I don't know how much damage a Mortar hit is, but I'm pretty sure it's like 300 or maybe even more. And then I'm obviously that's a cycle for the Evo anyway. And I can guard the Mortar with the Inferno Tower. And they can't outcycle me because I have the Mortar and the Inferno Tower. And so I'll put down a Mortar, and then I'll put down the Mighty Miner like 2 seconds later. And so they'll always respond to the Mortar with something. And most of the time, the Mighty Miner can just kill it by lane switching. If they drop a Mega Knight or something, the Mighty Miner can solo it. And if they drop a Swarm, just switch lanes. And the Mortar is there unprotected. And then what I find normally works is they then save up some elixir to play something else. And as soon as they play something, I just put the Inferno Tower in the middle in range of whatever troop they've played. And that does the trick. And it's really nice because I've got quite a lot of cheap cards, like Skeletons are only 1 elixir, Log is 2 elixir, Dark Goblin is 3 elixir. So you can cycle pretty quick. And because obviously Mighty Miner is a champion, it's pretty easy to like cycle back really quick. And Royal Recruits, I know that everyone says they're like a normie card, but they're really good. Evo Royal Recruits. Again, one more thing and then we'll go back to some maths. But Royal Recruits, Evo Royal Recruits, people still don't know how they work. And it's so funny because so they come with shields, and once the shields are broken, they will charge like a prince or a dark prince. And people don't seem to know that. I've played so many people where they'll think that they're sly by fireballing or arrowsing my Evo Recruits when they're on top of my Princess Tower. And I'm just like, dude, now they're just charging. Like, you've wasted. It's just an obviously bad elixir trade. Don't put a spell on them because now they're charging. Like, people don't understand this. You have to spell them when they're close to your other card so they can't charge. It's like when you counter a prince, you wouldn't put a card really far away from it. You'd put it right next to the prince so that it can't charge. It's basic. It's so simple. People don't really seem to understand that. But anyway, try that deck. Again, Evo Mortar, Evo Royal Recruits in that as well. And oh my god, it's really good. I tried it with Evo Dark Goblin, but instead of both of them, instead of Evo Mortar and Recruits, but I don't like Evo Dark Goblin that much. It's really annoying to play, but I'm not very good with it. Yeah. Charlie says, I genuinely never knew that what activated. Yeah. So they charge like a prince. So once they lose their shields, they will start charging. So you've got to make sure that you don't remove their shields when they're far away from your stuff, because then they're going to charge and obviously do more damage. So you got to be careful. If you want to arrows them or something, arrows them when they're near your own cards so they don't have time to charge. But do not fireball them from the other side. Like, definitely don't fireball them, because that would be like fireballing guards, just to get rid of the shield. It's useless. But you said I have Evo Mortar, but not Recruits though, so I'll have to spend 6 shards. Evo Recruits are really, really good. They are really good. It's a very versatile card. Yes, they're easy to play and people get annoyed by them, but they are really, really good, so I'd recommend it. I've got and then we'll move on, but I've got Mortar, Royal Recruits, Dark Goblin, P.E.K.K.A, Barbarians, I think I have more than that. Valkyrie is somewhere. Wait, let me try that again. Mortar, Recruits, Dark Goblin, P.E.K.K.A, Valkyrie, Bomber, Barbarians, Battle Ram, and I think that's it. So yeah, that's kind of what I do. You've got Evo Cannon, Mega Knight, Royal Giant, Bomber. Yeah, it's pretty strong. Did you vote Evo Valk? Yeah, I think I did. I can't really remember, to be honest. I think so. What, in that event? Yeah, I think I did. I don't even remember. But I don't like. I've got a mate that doesn't like Evo Mega Knight, and I don't really like Evo Valk that much, because my mate has this argument. I don't really get it, but he says that he actually doesn't like Evo Mega Knight. He'd rather have normal Mega Knight because, I guess, I don't even know what his point is, actually, now that I think about it. I just think he doesn't like it for some reason. And I don't like Evo Valk because I think that it can sometimes be detrimental to use it. Had to be the 5-star drop. Yeah. Yeah. But I think like a lot of cards like the like Royal Giant. Royal Giant is a really good Evo, I think. But it's very situational, like it just very much depends on the deck that you use. Because for example, if someone has an Inferno Tower, then the Royal Giant is a little bit cooked. But if they only have a bunch of swarm stuff, then it's really strong, obviously. So yeah, but that's why I think having a building in your deck is really good. Like it just counters so many things just by it being there. Even if it's a goblin cage, you know what I mean? Like a building's a building. Mega Knight chucks the cards away from your tower so it doesn't get hit. Yeah, it chucks them away from your tower so it doesn't get hit, which is, yeah. Like it is. I mean, it's definitely annoying to play against for sure. But I think he had an issue with it. Like, I think his argument was that it just has a lower DPS. The Evo Mega Knight has a lower DPS than the normal, because instead of being able to continuously hit, it's doing this thing where like it chucks it away and then it has to walk over to it again and then hit it again. So there are situations where Evo Mega Knight is worse, but as long as you play it right, I mean, that can happen a lot of the time. You can play, there's placements that you can make that literally just like are detrimental. Like they're not bad, they're just actually just detrimental. They make your tower take more damage, they make your troops take more damage. So it just depends how you play it, but yeah, I'm a big fan of it. I'm a big fan of the old Clash Royale. Bit of a Clash Royale gamer. Anyway, maybe we'll talk about Clash Royale in a bit more detail later. Don't even get me started on like Fortnite. Do not get me started. Okay, guys, let's finish off this question because it has been a little bit of time. That was a little break. That was just a little mental break since we've been going for about an hour now. So let's see what we can do about part B. Also, do you usually play recruits at the back to make the push? Yeah, but I don't normally start the game with recruits. Normally, I start with the mortar if it's in my hand. So normally, I'll place a mortar in the corner of like the bridge, so not in the middle. I place it in the corner because it's like there's less. Your opponent has less options to play it. So like the farthest to the right or the farthest to the left you can get mortar on the bridge, obviously mortar, and then give it like 2 seconds for them to put a card down, or like to anticipate putting a card down, and just put the mighty miner right next to the mortar. And then whatever they play, there is a seriously high likelihood that you will counter it with the mighty miner. And if you can't counter it with the mighty miner, then you go into your skeletons or your Inferno Tower or something like that to try and counter it. Sometimes if I don't have much elixir, I'll place the mortar and then the skeletons next to it, just to buy me a couple of seconds of time in case they play a P.E.K.K.A. or something like that. Or if they play a giant or an ice golem or something like that, the skeletons will actually do a decent amount of damage while it's destroying the mortar. But yeah, that's what I would say about that. And if none of that works, yeah, you got the Inferno Tower. So if I know that they don't have a troop that targets towers, like if they don't have a Ram Rider, if they don't have a Battle Ram, if they don't have Wall Breakers, if they don't have Hog Rider, etc., then I will quite comfortably place a mortar and then give it again about 2 seconds and then put the Inferno Tower down next to that. Because it's very common that someone will try and counter a mortar with a Tesla, but you can melt the Tesla with the Inferno Tower. So, yeah. Anyway, yeah, but recruits normally come in like fairly late game, I would say, or as a surprise. So they might try and like pressure you from both lanes without even knowing that you have the recruits, and the recruits go down. And of course, recruits are really good because sometimes I don't split them 3 and 3. I split them like 4 and 2. And people kind of sometimes they'll just ignore the 2. So yeah, but that's me. Anyway, Vidya Shankar, and I'm not even going to attempt your surname, unfortunately, because I will butcher it. but you say hi. I say hi too. Hello. We're doing some A-level maths, or we were doing some Fortnite, but now we're doing some A-level maths again. Not Fortnite, Clash Royale. That's what I meant. Yeah, don't get me started on Fortnite. That would be a bit crazy. Okay, right, let's go back into this question. So, if we actually remember what's going on here, the mean score on the test for the sample of 80 people was 102.5. Comment on this observation in light of the critical region. Yep, so basically, I think Charlie was 100% right there. Because the critical region is 103, or anything bigger than 103.29, we've got 102.5, which is less, so it's not in the critical region. Therefore, we would fail to reject the null hypothesis. We would not reject the null hypothesis because we're not in the critical region. And I'm going to go back up to what Charlie said a moment ago. You got, so, okay, so Charlie, you did it a slightly different way, which is absolutely fine. But you got 0.02524, which is greater than 0.025. So you've done it by not looking at the critical region, but rather by finding what you would call the p-value, or the probability of that happening. So that's completely fine, by the way. No problem with that. You'd still get all the marks. But I'm just going to do that to check it's right. So just typing it back into the calculator here. Give me 2 seconds. So lower is 102.5, upper, big number. Standard deviation 15 over the square root of 80. And mean is 100. So you've got... so Charlie, you've got 0.02524, but I've actually got 0.068. Have I made a mistake? Have I made a little mistake here? I don't know. So I've got, for the p-value, I've got 0.068. So we would still come to the same conclusion. But Charlie, see if you can check that. Do the calculation again. If you've got 0.025 something, then you would still come to the same conclusion, but we do have different numbers. So let me know what your thoughts are on that. And I'm also just going to go and check the mark scheme as well, just to see who's right. I mean, we're both right, but we just have different numbers. But we've both said that we can't reject. Well, in the mark scheme, in the textbook that I've got this out of, they've not used the p-value. They've just used 102.5 is less than 103.29. So they've said there's not enough evidence to reject the hypothesis, which we both agreed on. You'd normal CD lower 103.28, then a large number 15 over root 80. Mu is 100. So you've got the lower as 103.28. Okay, so because you've put the lower as 103.28, you actually 103.28. You should actually get pretty much 0. So okay, try this, right? Try to, let me just go to where are we? Charlie, try to type in this number here, 103.2869596. Type that in instead of 103. Just like 28 or 29, and you'll see that what happens is you will get exactly 0.025. Okay, so 103, let's do it together. 103.28. Well, it might not actually work because it might round it, I don't know. 2869596. It might round it. No, it's pretty. No, it's got 0.0249999999751. Okay. Yeah, you see, you're getting very close to it. So the reason I'm saying this is because what's happened, and my hair is literally so weird. What's happened is you've typed in the boundary of the critical region, and as a matter of definition, the critical region, if I go up here, we actually found the critical region by working out using the inverse normal to find you see it's actually definitionally the being bigger than it will be 0.025. The probability of getting a number bigger than this is 0.025, because that's actually the way that we defined that value, the critical region. So you can't use that number. What you have to use is the test statistic, is what you call it in the question. So instead of 103 point whatever it was, you've got to use 102.5. Okay, 102.5 if you want to do it that way. Okay, tell me if that makes sense. So lower is 102.5. And you should get about 0.06 as your final answer. Let me know if that makes sense to you. Yeah, you get that. So hopefully it makes sense, right? So yeah, you got to use the actual value in the question to fully do it. But just to be clear, for this question, you do not need to find what you call the p-value, which is what you've just found, the 0.06. That is the probability of getting that data or being that far away from the mean, or even worse, even bigger. And because it's not less than 2.5%, we would fail to reject the null hypothesis. So you don't have to do that though, because what you can do is simply find the critical region, which we've done. And then once they've given you this number of 102.5, because this number is not in the critical region, we automatically can say fail to reject the null hypothesis. We do not reject the null hypothesis. So you could say we accept the null hypothesis automatically without doing anything further on the calculator, simply by the nature of 102.5 not being in the critical region. The critical region, once again, being the region where you would reject the null hypothesis. It's not in it, so you don't reject the null hypothesis. Boom, done. Does that make sense? Hopefully that makes sense. And other than that, that's basically it. And then all you got to do is, as a conclusion, in a real exam, you would then write what I just said. So you would write down in plain English, you would say 102.5 is smaller than 103.29, therefore fail to reject the null hypothesis. Or you could say, do not reject the null hypothesis. And the very, very final thing is to comment on this in terms of the question, in context of the question. So not only do you have to say, I'm not rejecting the null hypothesis, in context of the question, what that means is that there is no evidence to suggest that eating chocolate before an IQ test will increase your score. So you need to say that as well in the exam. You need to say, therefore, there is not enough evidence, or there is no evidence to suggest that eating chocolate before an IQ test will increase your score. Okay. And that would be all the marks. And that would probably, overall, that would probably be about 6 marks worth of question there. Yeah, that makes sense. That part was a lot more simple than I thought. Yeah. In many ways, it actually is. Okay, guys, let's go through another question like this, because I think that'll be worth it. Okay, so let's go to, where are we? I'm just going to chill my face there for a second, and I'm going to make a new question. The reason why I want to go through an actual past paper, but for some reason I tried to download it and it didn't let me upload it onto the whiteboard. I don't know why. I'm going to try it again now. That's why I'm going through, these questions are from the Edexcel textbook, but it literally didn't let me, do it. It didn't let me upload it onto Microsoft Whiteboard. So, oh, and I'm actually getting let's just take a little 2-minute break and I will be back in just 1 second. Okay, guys, I am back. Thank you, everyone, for staying tuned. Yeah, we can keep going. Right, so, right, I have actually managed to get us and again, my hair is just terrible. I've managed to get us a past paper up. This is EdXL, and this is from 2023, and it's another normal distribution question. And I think maybe we'll end up with this one. We'll finish up with this one because I know we've been going for an hour and 25 roughly. I think it's been going pretty well so far. But yeah, this is unless again, if anyone has any other suggestions or anything like that of content that they want to go through, then of course I'd be very happy to do that. So just let me know. But we'll go through this big question here, if everyone is ready. Okay, and sorry that the quality is a little bit bad. Yeah, it's not the greatest quality, but hopefully it's still usable. Okay, cool. So a machine fills packets with sweets, and a seventh of the packets also contain a prize. The packets of sweets are placed in boxes before being delivered to shops. There are 40 packets of sweets in each box. The random variable t represents the number of packets of sweets that contain a prize in each box. State a condition needed for t to be modeled by a binomial distribution with 40 trials and a probability of success of 1 in 7. So does anyone have any ideas on any condition potentially needed for that to be a suitable model? Okay. Does anyone have any ideas? Should we be able to see the question? Oh, can you guys not see it? Let me know right now, guys, if you can't see it, because I need to get on that. If not, let me just preview this. Oh my god. Yeah, I've just realized you guys can't see the question. That's really weird because it's saying that you can. Oh, thank you, Charlie. Let me try and maybe refresh my page. Please do just let me know if you see it. At any point. Still with the technical difficulties. Let me remove it and start it again. Can you guys see that now? No, that's so strange. It says I'm sharing my screen. Oh wow, that's really funny. Okay, let me try and literally close that page altogether. Try and reopen it here. Okay, share screen, whiteboard, add to stage. Okay. Let me know if that is visible. That's the question. Super strange that it wasn't appearing. Yeah, that's good. So, okay, so it is, yes, okay. Yeah, thank you very much, Charlie, for that. Yeah, lovely stuff. Lovely stuff. Okay, cool. Yeah, so let's go through this. Please do just let me know if the same issue happens again, by the way, because I'd very much like to know. So let me just start this again. So a machine fills packets with sweets, and a seventh of the packets also contain a prize. The packets of sweets are placed in boxes before being delivered to shops. There are 40 packets of sweets in each box. The random variable t represents the number of packets of sweets that contain a prize in each box. State a condition needed for t to be modeled with a binomial distribution of a sample size or n 40 trials and a probability of success of a seventh. State a condition needed. So if anyone has any ideas, please do let me know on a condition that might be needed in the context of this situation to be modeled there. So SAR says n is large and p is close to 0.5, or is that normal? Okay, good knowledge of being able to make the distinction. So you do not need n to be large or p to be close to 0.5 to model any situation as a binomial situation. You only need that when you're modeling or approximating a normal distribution with a binomial distribution. So if you are approximating a normal distribution with a binomial distribution, then n needs to be large and p needs to be close to 0.5. No, don't say sorry, that's okay, you got mixed up, that's fine. It's simpler than that, potentially. We need to speak about the conditions for something to be able to be modeled with a binomial distribution. And so, for example, the probability of, a packet containing sweets, or sorry, the probability of a packet containing a prize needs to be constant. It needs to be always 1/7. It can't change as the situation changes. As you keep opening packets, it can't change. So P is constant. Me just said, I just finished my GCSE maths. What revision resources should I look at? So me, I'm assuming you're going to be doing A-level maths. Can you confirm that? Can you confirm that? So while me is confirming that, that's one thing that you could say. Another thing that you could say that's probably the best thing to say from each other. I think I just lost my picture there for a second. They're all independent of each other. So when you open one packet of sweets and there's a prize in it, it has no relation to the probability of the next packet having a prize in it. They're all independent. So in the mark scheme, it says comment in context about either independence or random packing, e.g., prizes must be placed in packets at random or independently of each other. Or you could say about the constant probability, e.g., the probability of a packet containing a prize is constant or the same or fixed. Okay, so either of those that I said would be sufficient to get the marks. SAR says, start doing the exercises from the textbook. I literally couldn't agree more. You're doing A-level maths and want a head start. So yeah, me. First of all, make sure that you know what exam board that you're doing. So make sure that if you're doing edXL, you got the edXL textbooks. If you're doing AQA, get the AQA textbooks. Find out what exam board you're doing. Once you know that, oh, how long is this stream? It's just going. It's just going as long as it goes. I mean, I'm definitely going to finish before 3 o'clock. So it's going to be no longer than another half an hour. But please do just ask questions. I'm very happy to go through anything that you want. As long as we need to keep it somewhat A-level maths related though. It's got to be A-level maths content for the last paper. Yeah, but please do feel free to ask away. I'm basically just doing free tutoring right now. When I do tutoring, this is what it's like, kind of, maybe with a bit less yapping, or maybe not. I'm a bit of a yapper. But anyway, so yeah, find out what exam board that you're doing, and buy the books. Buy the books. Purchase them. Have a physical copy of them, as well as the online version, of course, as well. And just like what Sar said, go through the textbook. Start answering questions from the textbook, okay? Because this is what I did, and it worked out pretty all right for me. I got an A-star in A-level maths. I did Edexcel. All you've got to do is you've got to open up those Edexcel textbooks, or whatever they are, and once you start year 12, or over the summer if you want to get ahead, open the textbook, chapter 1, section 1, question 1, write out the entire question and answer it. And then immediately after, check the back of the book, put a little bookmark in the back so you can keep flicking to it, see whether you're right, and then go on to the next question. Do the same thing. Go on to the next question. Do the same thing. There are thousands of questions in that book, or in that series of books. If you are serious about this, there is no harm in answering all of them. And that's what I did. Now, guys, I don't think I've really given out my origin story on this YouTube channel yet. But very, very briefly, when I started year 12, I was very much I was someone who did not care so much about my education. I really wanted to do engineering at university, but I had no interest in maths. Well, we'll do part B in a second, so sorry, I'm yapping. I had no interest in maths at all. I just really wanted to be an engineer or a physicist or something like that. So I was like, I have to do it. I have to. My plan was, if I can just get like a C, then I can go to a decent, okay university, and it will be fine. I start sixth form. My predicted grade in A-level maths immediately is like a D. They give me a D because I do so badly on the baseline assessment. It's a GCSE level assessment, first week of A-levels. I get 19 out of 64. I was the only person in the class that my teacher put my exam script upside down on my paper when we got it back after it being marked, because he didn't want other people to see how badly I'd done. I got literally the worst mark in the class. And obviously that's very demoralizing. I only got a 6 in my maths GCSE. So I didn't actually know a lot of the GCSE content, believe it or not. I genuinely didn't know how to do basic SOHCAHTOA. I didn't know how to factorize a quadratic equation. I didn't even know what completing the square was. I'd literally never even heard of it before. I was really on the back foot. And this is, by the way, this is 2020, September 2020. As you probably remember, in the Christmas of 2020 to 2021, we all went home from school for Christmas. And then because of COVID, we didn't come back until whenever it was, April or something like that. So over that time, I was like, right, I've got months and months, and I'm going to lock in. I'm going to make sure I know all of this content. And the idea is, eventually, I'm going to get behind again. But if I get behind after already being ahead, then I'm just in the same place as everyone else, and it's all fine. So I was getting ahead to stop myself from getting behind. And I got to I believe it's chapter 11 in the book, something like that. The differentiation chapter, whatever chapter number that is, chapter 11. And I tried to teach myself differentiation because we hadn't done it in class yet. And you can imagine, based on what I've said, it probably didn't go very well, right? It didn't. And I didn't know what I was in for. I didn't know that it was supposed to be quite a hard topic. And I was trying to really, really, really understand it and wrap my head around it. And it took me a long time. It took me like an entire evening, and then probably the next day as well. And I was watching YouTube videos and all this stuff. And eventually it just clicked. There was one moment where I was just sat there and I was like, oh, I get it. I actually get it. And in hindsight, I think I can look back on that moment and say that is probably the moment where I begun to really, really genuinely enjoy maths and see the appeal of it and get the satisfaction, because it felt so good. It felt so satisfying, especially as someone who felt very, outmatched by mathematics, to finally conquer a topic. It was great. And from there, the rest is history. I ended up teaching myself A-level further maths because my sixth form didn't actually offer it. I had some help from my A-level maths teacher. He was really, really, really helpful. But I didn't, by all means, I did teach it to myself. And I got an A in A-level further maths when I had a 6 in GCSE maths. So I'm talking mostly to me, the person here. You might say, how did I do this? How did I do it? I literally did answer every single question in those books, in those blue books, in the Edexcel ones, and then in the brown/red ones, the mechanics and stats ones. And then I did the further maths books. I did obviously Corpio 1, Corpio 2, and I did further mechanics 1 and further stats, further mechanics 1 and further pure 1. Since then I've now done all of the modules except decision 1 and 2. But that's it. What paper is this? This is Edexcel 2023 statistics. Ashana. And let's go into a question, because I am yapping now. Because someone's asking what's the answer to part B. But yeah, this is 2023 Edexcel statistics. Obviously, it's paper 3. Okay, let's go into part B then, because I've yapped enough. But the point is, if you're starting A-level maths, the best thing you can do is open up. Okay, anyway, so a box is selected at random. Using T is distributed with a binomial distribution, 40 trials, probability of success 1/7. Find the probability that the box has exactly 6 packets containing a prize. So all of this is just calculator work. So we're going to go into the calculator. Exactly 6. So we need binomial PD or PDF, if that's what your calculator says. And I will write down exactly what needs to go where. But you're going to have X. Oh, sorry if you guys heard that loud noise. You want to have X as the number. Is it going to load? Is this? There we go. So you want to type in X as the number 6. You want to type in N, the number of trials, as 40. And you want to type in P as 1/7. So 6, 40, 1/7. Got 0.1727 is going to be the answer to that one, okay, or 0.173. Okay. Me says, anything I can do outside of textbooks for the time being. Do you want the honest answer? Me, do you want the honest answer? I don't know exactly. I mean, it's very simple to, I do this a lot with uni. When I know I'm going into the next uni year, it's like, I should really get ahead, but what can I do without just reading the lecture notes or without just going through the textbook? To be honest, there's nothing that you can really do aside from going through the textbook or just going through the same content that's in the textbook from a different source. So you could watch some YouTube videos and stuff like that, but seriously, the best thing to do is open up the textbook and start doing questions out of it. And you might not like the sound of it. You might say, "Oh, I don't really want to do it. Yeah, I don't like this." Just do it, and I guarantee you'll start to derive a bit of satisfaction or enjoyment out of it after enough time has passed. as well, if you respect the textbook, if you really do every question in that book and you write out every single question, etc., I guarantee you'll find like a real, it's like you've got to complete the textbook and all that stuff. It's fun. I found it fun. Charlie says for part B, I get 0.06159. Let's check it out in a second. Sar says for a normal distribution, when applying a continuity correction, how do I know whether to add or subtract 0.5? Sar, could you elaborate a little bit on what you mean by that? I'm not 100% sure what you mean when you say to apply a continuity correction. Can you just elaborate a little bit, and I'll get back to you in a second. For part B, the probability that the box has fewer than 3 packets containing a prize. Let's check it out. So we're going to go binomial CD. Fewer than 3 means 2 or less. So X is the number 2, not the number 3. And N is still 40 and P is still 1/7. So, yeah, we've got 0.061587. And that is, yeah, that's what Charlie got as well. So, yeah, Charlie is absolutely right. He's got his profile picture as Clash Royale. Ha 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 ha. That's crazy. That is a crazy switch up. We love it. All right. Mises, thanks a lot. I don't know if I can obtain one, so I'll just try and find an online one. Thanks a lot. So yeah, I mean, again, make sure that you know what exam board you're on. If you know that you're on EdXL, I know that, you know, some people can't afford things like that, but the textbook is about £20. The first year, like basically the AS content, it's 20 quid. It is one of the best 20 quids you could ever spend because it's really, really important to have that textbook. So if you have £20, get it. Pay for it, buy it, and you get the online version with it once you've bought the physical copy. Sar says, so when converting from a binomial distribution, like the mean equals NP, etc., we must apply a correction to increase the range. Oh, I think I know what you're talking about now. Okay. So you're saying when applying a continuity correction, how do I know whether to add or subtract 0.5? I can sell you mine. I can sell you mine. I have both pure and... Guys. Get in contact. Charlie says your school will probably have them as well, so you can always borrow the textbook. That's very true, actually, Charlie. So if you haven't like finished for summer yet, I know you just said you just done your GCSEs, so you might not have any plans of going back into school. But see if it might not be that easy, but see if you can ask, maybe email a teacher and say, hey, look, I'm going to do further. I'm going to do A-level maths. Can I please come in and grab a textbook so I can have it over the summer? There's a chance they might say, yeah, that's okay. There's a chance that they might say, yeah, sure, come and get it. They might also say no for a variety of reasons, but it's actually worth asking if you don't want to spend the 20 quid. Oh, thank you. Guys, the wife has just brought home the goods. She's not actually my wife. I'm a bit too young for that. That's lovely. That's delectable. A little sweet treat. Sorry if you guys hear that. Okay, cool. Right, let's go into this. Yeah. So after this, we'll go through converting to binomial, and then we'll call it a day. Okay, guys. Unless anyone else has anything. This has been a really good live stream, by the way, guys. This has been good. Like, there's been a lot of activity in the. I like it when people actually comment, like, "Can we go through this?" And I'm like, "Yes." You know, I'm a yapper as well, but so I'm going through stuff slowly. But you know, it's fine as long as you guys are entertained. As long as you guys are deriving something out of it. Okay, so cool. Right, part 3. Camille's sweet shop buys 5 boxes of these sweets. Find the probability that exactly 2 of these 5 boxes have fewer than 3 packets containing a prize. So this is where we get a little bit lost in the weeds, right? Because there's a lot of stuff going on. Like, it's very, you know, by the way, guys, while I'm talking, please give it a go yourself and see what you can do with part C there. But we know that the probability of any given box having fewer than 3 packets, or the probability that the box has fewer than 3 packets containing a prize. Did I actually write down the answer to that one? I'm so sorry, guys. I don't think I actually wrote down the answer. Let me just write it down. So I got distracted. It's 0.06159. Is that what you guys got? Someone said that, I'm pretty sure. Yeah. Charlie said that. You're absolutely right, Charlie. Well done. Lovely. Ha 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 ha. Hee 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 ha. There we go. Okay, cool. Yeah, so Sar, I mean, you know, sell me your textbook. Not me though. I don't need your textbook. I've got all of them. Don't sell me your textbook, but sell me your textbook. Okay. Right. You guys can get in contact somehow without putting all of your personal information on the internet. All right. So, how are we going to do part C, guys? Have a think about it. We already know the probability that a box has, because we have now boxes, and a box, let's see, what does it say about the boxes? A machine fills packets with, let me just make sure I'm fully understanding the question. It fills packets with sweets, and 1/7 of the packets also contain a prize. The packets of sweets are placed in boxes before being delivered, and there are 40 packets of sweets in each box. Lovely. Cool. So the probability that the box, any given box, has fewer than 3 packets containing a prize is 0.06159. Camille's sweet shop buys 5 boxes. So, guys, we now have another binomial distribution on our hands. Let's write it down. So now I'm going to use a different letter. I'm going to use y this time. I'm going to say y is binomially distributed, and there's 5 boxes. So there's 5 trials, and the probability of a success, which is that they have fewer than 3 packets, is 0.06159. And we want the probability that y is exactly 2. Okay. Tell me if that kind of makes sense. You've got 0.031, etc. Let's check it out, Charlie. Let's check it out. So the probability that y is 2, going back into the calculator, going back into the calc. Calc is short for calculator, by the way, guys. I'm just using slang. Right, going into it. So binomial PD, because it's exactly 2. Number of trials is 5. Probability of success is 0.06159. And X is 2, yeah. And yeah, I mean, I've got the same thing as you, Charlie. So I've got 0.0313. 0.03135. And that is what you said that you got as well, right? 0.03134. Yeah. 0.031347. Yeah, good. Okay. And yeah, that is, let's check it out. That is the correct answer. 0.03134. They've actually written 44 there, but you're allowed anything in that range. So we're right. We've got the marks there. So well done. Well done. Can I it says I can star. I've just starred your answer, but I don't think it did anything. Okay. There you go. I've shared it with the rest of the world. Okay. Cool. So hopefully everyone is happy with that. Now we're going to go one step further. Camille claims that the proportion of packets containing a prize is less than 1/7. A random sample of 110 packets is taken, and 9 packets contain a prize. Sorry, I was just chewing on some ice there. Didn't want you guys to hear it. Use a suitable test to assess Camille's claim. You should state your hypothesis clearly. Use a 5% level of significance. Okay, cool. So guys, before I get into this, does anyone have any ideas on how we would do this? Does anyone have any thoughts? Obviously, the first thing that we should do is state our hypotheses. What do you guys think the hypotheses should actually be? So we've got H0, we've got H1. Does anyone have any opinions on what either of those should actually be equal to? Please do leave your thoughts in the comments in the chat if you've got any ideas. The null hypothesis is that P is a seventh, and the alternate hypothesis is that P is less than a seventh. Yes, you're absolutely right. Oh, and we've got two. Aspect has also said the same thing. A seventh and less than a seventh. Yep, you guys are both absolutely correct. So let's write that down. So P is 1/7 and P is less than 1/7. In a real exam, I would also explicitly write what P is in full English, where P is the probability of this or that or whatever. Just to be really clear, super clear in the exam. Okay. Cool. Now, what else should we do? First, I think the next thing we should probably do is write down the way that X is distributed, or, come up with a distribution. So I'll say, X is binomially distributed. And what are we going to say? A sample of 110 packets is taken and 9 contain a prize. So, we're going to have 110 trials here. We believe that the probability of success is 1/7. So this is what we're assuming that X is. And again, guys, we should say where X is a random variable, it's the number of packets containing a prize. Does everyone agree with that? Is everyone happy with what I've written? Does everyone understand what I've written? Please do let me know. And then we can move on. Charlie says yes. Lovely, lovely, lovely. Cool. All right. Now, what we should now do is we should calculate the probability of basically what has happened in the question of happening. Okay. So we get told that a random sample of 110 packets is taken and only 9 contain a prize. So absolutely, we might have reason to believe or to suspect that maybe P is less than a seventh, because it's weird. It's weird that that's it's so low. Okay, so we go binomial, CD, and what we want is to calculate the probability that we have got 9 or less packets. So N is 110. P is 1/7. And X is 9. And that's going to make it count 9 or less. Because the reason it's 9 or less is because if we had only 8 prizes or only 7 prizes, we'd also be doing a hypothesis test in this fashion. So it's not specifically the number 9, it's the fact that it's so low. So we want to see what's going on with the probability of 9 or less. Okay. And I found that the probability that X is less than or equal to 9 is 0.03829, roughly. Do you guys agree with that? Hopefully. So with that said, should we reject or accept the null hypothesis? Or should we reject or fail to reject, I could say, the null hypothesis? What do you guys think? Reject or not? You've got 0.859. Curious. How have you got 0.859? That's fascinating. Oh, got you. Okay. Yeah, 1 in 7. Okay. Yeah. And the thing is, by the way, Charlie, if this happens in the real exam where you make a little mistake like that, remember to look at your number. Like, in hindsight, does it make any sense that the number would be 0.859? Like, is the, it's think about the situation. 110 trials, probability of success 1 in 7. Is the probability of getting less than 9 really going to be like 90%? No. So you can easily go, oh, wait, this must be wrong, because you would expect a much lower number. The fact that you're doing a hypothesis test is like you're going to have a fairly small probability. Anything bigger than like 0.1, I'd be raising my eyebrow at it, to be honest. I'd be like, what? Is that definitely right? I mean, not that it can't be, but just it's a bit of a red flag. Okay, cool. So yeah, we get 0.0. Let me just move my screen. There you can see 0.03829. And absolutely, with that value, we are rejecting the null hypothesis because we're testing at the 5% level and 0.03829 is less than 0.05. So because 0.03829 is less than 0.05, we reject H0. Okay. And again, when you do a hypothesis testing question, what you should also do is write down in plain English what you've actually deduced. Okay. So in plain English, what's happened? Well, we've said that there is evidence to suggest Camille's claim, which is that the proportion of packets containing a prize is less than 1/7 or 1 in 7. Okay. There is, so I would write this down in the exam. There is evidence to suggest the proportion of packets containing a prize is less than 1 in 7. Write that down at the end. I won't do it now because it's just, you guys don't need me to write that down. But please, can I get a show of thumbs? Can we have some thumb emojis, please? Thumb emojis. Thumbs up, thumbs down, and if it's medium, just any emoji. Except the thumbs up emoji or the thumbs down emoji. Come on, guys. Give me the maybe the Easter Island emoji. I like that. If that's like, if you're unsure, you guys know what I'm talking about, the Easter Island. I like that one. Charlie says thumbs up. I love it. Okay. All right. Cool. I think that's everyone that might be following it, but that's good. Okay. Amazing. All right. Now, as promised, I want to look at approximating a normal distribution with binomial. I don't know if there already is one in this exam. I hope there is, but there might not be. Let me have a quick scan. Oh, this is a cool question. Wait. There's an integral in the question. That's interesting. Okay. Nonetheless, we've got to stay on topic, guys. Got to stay on topic. It's not here. Let me look for it. Guys, I'm looking for a very specific type of question. I want approximating a binomial distribution. Do you know what? I might get one out of the textbook because it is easier. Approximating a binomial distribution, or sorry, I keep getting it the wrong round. Approximating a normal distribution with the binomial. Let's see what we can do. Because was it Saw? Someone asked about it. So now we gotta follow through. Guys, if you appreciate this content, please do leave a little sub or a little like. It really make me smile. Okay. All right, approximating a binomial. So let's just go through this content nice and quick, and then I will call it a day fairly shortly after this. So just as a recap of this topic, because also some people might just genuinely not remember how to do it, which is completely fine because so what's going on? Well, you can be given questions where you have a normal distribution, and for whatever reason, you need to approximate it using a binomial distribution. So let's say that we have x is normally distributed with a mean of mu and a standard deviation of sigma. This is how we would write our normal distribution. But we can also approximate it like this. It's binomial, and instead of the mean being mu, or approximating a binomial distribution mu, it's NP, and the variance is NP times 1 minus P. Okay, so that means that mu is NP, and the standard deviation, sigma, is the square root of NP times 1 minus P. Now, guys, as to why, especially the standard deviation one, is true, that's a little bit complicated, so I'm not going to go into it. Simple, like it's pretty simple to be able to deduce the way that you get like mu is NP, but the standard deviation is slightly questionable. But again, I'm not going to go into it now. But it's probably better to know a little bit more maths before going into that. So don't worry about it. And you can basically be asked questions that make you do this. And I'm just going to quickly run through one. And I think then... Can you still hear me, guys? Oh, Charlie, you're my man on... Guys, can you hear me again? Thank you for letting me know, by the way, Charlie, that it all went a bit wrong. Hassan says, appreciate your teaching. I'm watching from Bangladesh. Wow. Thank you so much for watching from Bangladesh. I really appreciate that. Thank you so much. Check out the rest of the channel for more maths videos. I don't only do A-level content. 2 music videos, loads of maths videos. Yeah. I'm trying to do some like brain rot thumbnails. My most recent video that I posted yesterday, it was like Ed Sheeran, but as a Muslim. And it was a video on how to do an interview. It was a math video. But I just titled it "Eight Sheeran." Because that's just fun. But the thing is, a lot of my audience are Indian because of like JEE and that kind of thing. But I need to tap into the Indian brain rot because I feel like I only know Western brain rot, you know. Western brain rot is stuff like John Pork. Maybe that's a little bit old. Marvin Beak, a bit more recent. But there's obviously Italian brain rot, like Tralalelo, Tralala. But who cares? Indian brain rot. I need Indian brain rot for the thumbnails to get a wider audience. Anyway, that's enough yapping. So guys, let's go into this question. Let's share the screen, the whiteboard. And guys, please let me know if you can see the whiteboard now. Please do let me know. As I say, we're going to end this in a few minutes, but I'm just going to do one question to answer. Was it SAR? Yeah, SAR's question. Thank you very much, Charlie. Okay, right. Cool. Right, I'm just going to lose it for a second. I know it's gone now. I know it's gone. Just bear with me. Okay. And it's back. Cool. Hopefully you guys can see that, but please do just keep me updated on this. So this can be the last question that we go through, okay? So a drill bit manufacturer claims that 52% of its bits last longer than 40 hours. A random sample of 30 bits is taken and X lasts longer than 40 hours. Find the probability that X is less than 17. So guys, this is just going to be a binomial question because it's got all of the common, just the common signs of it being a binomial question. It's, don't overcomplicate it. It is just binomial here. So let's do this together. We've got X is going to be binomially distributed with 30 trials, and the probability of success is 0.52. We want the probability that X is less than 17. So we're going to go into the binomial CD function. We're going to type in not 17, but 16, because we need the probability that X is less than or equal to 16, with 30 trials and a probability of success of 0.52. Okay. And the answer should be 0.6277. Okay, that is 0.6277. Hopefully everyone is happy with that. Yep, and Charlie says the same thing. Lovely stuff. 0.6277. Perfect. Okay, now this is the more interesting part. A second random sample of 600 drill bits is taken. And, oh, it says I'm connecting. I think you guys can still see this, though. So I don't really care about that. 600 drill bits is taken. Using a suitable approximation, find the probability that between 300 and 350 bits, inclusive, last longer than 40 hours. So, one, we might do this because you can see 600 is a really, really big number. And I'm just wondering now, but it might very well be that you actually can't do this on the calculator. It looks like it actually will allow it. Hello, 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 hello. Sorry, guys, it keeps kicking me out. I'm not really sure why. It probably is my internet connection here, but I do apologise for this. Hopefully you remember because we are going to end this. But just sharing my whiteboard again because maybe I've done this here. Please let me know if you can see it any second now. Not yet. Yeah. There now. Can you see that? Please let me know. But yeah, so 600 is a big number, so you might want to approximate it and do some easier calculations here. Okay, that's the idea behind why you do this. As someone said earlier, yes, you do need p to be close to 0.5 to approximate this with a normal distribution. And you also need the number of trials to be sufficiently large. In this case, we have both. So it's fine. So we can do it. And it would be a suitable approximation indeed. So let's do this now. Again, we can say that x is roughly going to be normally distributed with a mean of np, n times p, so 30 times 0.52, which is 15.6, and a standard deviation of the square root of np, so 30 times, or wait, why did I do 30? Sorry, guys. It's not 30. That's my mistake. Why did I do that? It's 600. So I don't know why I did that. So sorry, let me try that again. 600 times 0.52. So it's actually 312. That was my mistake. Sorry for confusing anyone there. And the standard deviation is the square root of 600 times 0.52 times 1 minus 0.52, all inside the square root. And so the standard deviation is 12.2376. Okay. Hopefully that makes sense. Does everyone agree with that? Please, could you move your camera? Oh, good point. Good point. There we go. Let me also move that. We go. It covers a little bit of what you're writing. Yeah, thank you for spotting that. Let me zoom out a bit so you can see that. Hopefully that's, yeah, there we go. That will all be visible at the same time. Hopefully you guys agree with this. And we want the probability that between 300 and 350 bits inclusive lasts longer than 40 hours. Okay. Now, first of all, inclusive just means including 300 and including 350. But when you do this with a normal approximation, I'm going to write this down. The probability, and actually, do you know what I really should be doing? Really, I shouldn't have called this x. I should probably have called this y, so that I can say the probability that x is between 300 and 350 is going to be approximately the same as the probability of y being between 299.5 and 350.5. So you have to go, to answer your question, Sar, you have to go 0.5 out of the interval. And that's just because if you were to draw a graph of the binomial distribution, it would look kind of like a bar chart. When you draw the normal approximation on top, it looks like a continuous smooth curve or blob thing. And it turns out that the areas do match up very nicely if you do this. Okay, so that's kind of the best explanation. And so we just go into the calculator, we go into the normal CD. Lower is 299.5, upper is 350.5. The standard deviation is 12.2376. The mean is 312. And the answer that you should get is 0.8457. Okay. So you've got the probability here is 0.8456500007. So 0.8457 to 4 decimal places. And again, I'll zoom out a bit so you can see all of this at the same time. Does that make sense to everyone? Are you going to be doing any mechanics? JN, I'm sorry. I'm actually not going to be doing any mechanics. I do apologize. The reason I'm focusing on stats is because the AQA people have already done mechanics, but no one has done stats yet. So I was just doing stats basically because it's just going to appeal to the broadest audience. I would do mechanics, but I am actually going to dip out now just because I'm actually doing a barbecue and it's already been 2 hours 20. So a very good live stream. I think a good turnout as well. But that's all I'm going to do for today, guys. I will do a live stream in the future. I want to do a live stream where I do 100 integrals in one go. And I'm going to call it, I'm going to show you guys the thumbnail for it because it's really cool. I'm going to call it one gorilla versus 100 integrals. Because there's the whole debate over who would win, 100 men or a gorilla. I don't know who would win out of one gorilla and 100 integrals. And JN says, enjoy the barbecue. I appreciate that, JN. I appreciate that. Let me show you guys this thumbnail because it's so much fun, guys. It is so much fun. Let me share my screen with you for a second here. Share my screen. Here it is. Guys, check this thumbnail out. We can't see it yet. There you go, guys. Check that out. Don't tell me the 100 men definitely win. I agree. A gorilla has no chance against 100 men. But would the gorilla win against the integrals? That's the question. But that's to be continued. So I've made 100 integrals and I've ranked them in difficulty level. So the basic integrals are called Curious George. It is tough, innit? It is tough. Thank you. So Curious George are the easies. And then the next level, I believe it was, I can actually probably, guys, I might as well just show you the document, to be fair. I did it on LaTeX. Let me just open this. And then we'll call it a day, guys. But you might find this funny. I will do this at some point soon. I'm just trying to find like a window to do it. And also some of the integrals are quite difficult. So I want to make sure I can definitely do them without too much, hesitation and stuff. That wouldn't be great. Let me just get there here. So yeah, I appreciate you guys saying that it's tough. It is tough, innit? Right. Yeah, I've got a lot of maths like side projects going. I don't know if anyone in here knows the band Glory Hammer. It's very unlikely, but if anyone knows Glory Hammer, please leave a comment. I bet no one does because they're a little bit unknown. Glory Hammer. No, but basically they're a band and they do concept albums, so they've got characters and stuff. And I've actually written a bunch. I've not finished it, but I've written a bunch of maths exam questions about the entire story of Glory Hammer. So it's like the same thing as writing a bunch of exam questions about, like, the events that happens in like the Lord of the Rings or like Star Wars or something like that. It's kind of like that. But I want to do a bunch of videos on that as well. So let me show you guys. Can I share my screen here? Share my screen. There we go. And boom. Okay. I'll have to make this a bit bigger here. So yeah, one gorilla versus 100 integrals. Where are we? Okay. Yeah, so 1 to 24 is Curious George. Guys, let me know if you'd watch a live stream where I do this. So we've got a bunch of integrals here. As you can see, I'll let you have a very quick look at all of them. Obviously, just pause the video if you're that curious, but You know, if you're that curious of a George. Curious George, that's level 1. Then we've got Bantu. If you guys don't know who Bantu is, Bantu was a gorilla that died quite soon after Harambe died, where they were transporting him to a zoo and they gave him like anesthetics and they gave him too much. So unfortunately, Bantu didn't wake up from his, you know, his slumber, which is very sad. So he's not quite as legendary as Harambe, but he's still iconic. And we have some slightly trickier integrals. If you're worried about the, if you're concerned about the difficulty level, they're a bit random because some of these are actually not that hard. But there's Bantu. PMO. Corey Borg. I don't know what PMO means. I'm kind of like a boomer kind of. PMO. All right. Next best gorilla, we've got King Kong. So we've got some, these are getting, you know, these are getting tricky now. Some of these integrals. Definitely looking tricky. I'm so curious what PMO means. Put me on. I don't understand the context of that. Put me on. I know what TS means. I won't say it because it's family friendly. But there we go. Anyway, we've got Caesar. Caesar, obviously, Planet of the Apes. Come on. He's a pretty powerful monkey. Got some pretty tricky looking integrals there. Now, at this point, we're pretty much beyond the scope of A-level maths. So if you're an A-level math student, some of these could look pretty tricky. Kind of beyond the scope of A-level further maths as well for some of them. And finally, we've got Harambe. There's not many of them, but these integrals are really, really difficult, as you can see. So I'm going to go through those as well. I'm going to go through all 100, but it's just about finding time to do it. But some of these integrals don't look that hard, but they really are. They're very difficult for various reasons. Number 99 is probably the easiest. Number 99 isn't too bad, but it's not that hard, but I'm going to do it in a cool way. I'm going to do it in a really complicated way. I'm going to use something called a Laplace transform. Yeah, so a lot of these are quite famous. 100, I've already made a video on how to do it. 94 is a function in and of itself, a function of n called the gamma function. 95, really, really famous integral, the Gaussian integral. 96 is what you would call a Wallace integral. 97 is pretty cool as well. It actually, believe it or not, involves pi squared over 6. And yeah, but I'm not doing any complex numbers stuff. I'm not doing any residue theorem stuff, guys. So I don't know if you know, well, most people probably won't know this, but you can actually use complex numbers in a very, very interesting way to evaluate integrals that look like this. Okay, and there's something called Cauchy's theorem, the residue theorem, etc. But none of these are on that because it's a bit too complicated. But I will do a part 2 at some point, I'm sure. When is this going to happen? JN, I'm not 100%. I think in a few weeks, maybe in a few weeks' time, we'll see. But I would, I've had this in the bag for a little while, and it's just about finding time to do it, etc. But yeah, that's the idea. So anyway, guys, I'll leave it there. Obviously, thank you everyone for joining me, and the most important thing is, you know, good luck to everyone on their, you know, for their exams tomorrow. If you're doing A-level maths, good luck. Charlie says, thank you for the help. Of course. So this is the last A-level maths one. Obviously, I'll be here next year as well if you're in year 12 or something. But obviously, I really appreciate everyone coming along and chilling out and doing some maths. If you guys do need any other maths help, there's a high chance that I've got a YouTube video on it on the channel already. So go and check out my other videos. I've got an A-level maths playlist, and also I've got a lot of A-level maths content that is just like randomly spread out across the channel. So if you're looking for something in particular, I don't have any statistics, but I do have quite a lot of other stuff, pure stuff. So feel free to check it out. I've also got a lot of cool videos coming up in the future as well, cool in my opinion at least. So yeah, once again guys, thank you so much for watching. I highly appreciate you chilling out with me for the last 2.5 hours, and I will be seeing you next time. All right, cheers guys.